Okay, they do not do those theorems. I gave you the theorems to try to make a couple of these proofs a little easier. They are not mandatory in a proof. You can get away with a proof without doing those three theorems and doing it a different way. But I just thought that we should expose you to those three theorems because, one, it makes the proof shorter and maybe a little bit more understandable if you tried to do it a different way. All right, so hopefully you wrote down three theorems on your index cards. Real quick recap on those three theorems. A is parallel to B, B is parallel to C. The first theorem says two lines parallel to the same line are parallel to each other. That's what the first theorem said. It is not substitution. I'm trying to drive that point home. Substitution only means if they are equal, I could use it. Okay? This is not substitution. It's the two lines parallel to the same line or parallel to each other. Second theorem dealt with same thing, but now replace parallel with perpendicular. X is perpendicular to Y. Y is perpendicular to Z. But be careful. Two lines perpendicular to the same line. You would think perpendicular again, but it's parallel. Two lines perpendicular to the same line are parallel to each other. Okay? All good? And the third one, I know it's wordy. It was wordy, sorry. Says the following. Let's see, I'll use R, S, and T here. If R is perpendicular to S, and S is part of a parallel line, let's say with T, then what's the relationship between R and T? They're perpendicular. Okay? A line perpendicular to one or two parallel lines is perpendicular to the other line. Here's my best piece of advice, guys. Look for repeaters. Look for repeaters. Look for repeaters. Two sets of parallel lines, two sets of perpendicular, one of each. You got a repeater in there, it's probably going to be one of those theorems. Okay? All right, homework you want to talk about. Let's start it. Anybody want to start it with any of these? Homeworks you want to talk about. We got a big day ahead of us. Zach? 3. Everyone take a look at the right triangle problem, number 3. Okay, little unique proof statement, right? I've never asked this before, that you proved to me that triangle FDE is a right triangle. And I gave you guys a little hint. I said, try to get to in your proof why FED would be a right angle. Try to get there. Because if that's a right angle, that's a right triangle. So how did I get to this point? How did I end up with angle FED being a right angle? Well, look at the two givens right now. I got a pair of perpendicular lines, and I got a pair of parallel lines. I got one of each, one perpendicular, one parallel, and I see the fact that AD is in both. So I know, hey, whoa, there's got to be a relationship between the other two lines, DE and FB. I just got to figure out what's the correct theorem out of those three. So DE is perpendicular to what? Just stay with me here. DE is perpendicular to what? And isn't AD a parallel line? With what? FEB. So those two have to be perpendicular. And I know this is a long one. So a line perpendicular to one of two parallel lines is perpendicular to the other line. What is that? That's garbage. And then where two perpendicular lines meet, what's formed? Right angle. That's how I get angle FED to be a right angle. Perpendicular lines, now that I know they're perpendicular lines form right angles. You could also do Definition of perpendicular. I know some of you like to do that. And then what type of triangle do I have now? I don't know if it's scalene, isosceles, but at least I know it's a right triangle. So triangle FDE is a right triangle. And then the reason, just tell me something. I wouldn't use definition of a right triangle, but tell me something. How do you know it's a right triangle? Because it's got what in it, Dave? Right triangles have right angles. Or FDE has a right angle in it. Something. All right, we good? Next, others or questions about 5, everybody. Oh, yeah, 5. If you don't know me that well yet, you will, I think you've noticed multiple times so far this first quarter that sometimes the homework questions don't match what we did in class. Sometimes they review what we did a couple days ago, and that's exactly what this one did right here. Some of you guys were just in the mode of, I got to use an index card theorem. I got to use a new theorem. Got to use a new theorem. No. You could not use a new theorem here. You couldn't. Is anything parallel to the same line up here? No. You guys don't force it. Just because it's index card theorem day doesn't mean homework all has to be about that. Okay, so how do I do this one? You can still do it. We've done one similar to it before. You know what parallel lines form? Alternate interior, corresponding, same side interior. They form a line. I'm not too sure which version I put on the answer key, but I'll do one version right now and talk about the second at the end. Okay, everyone ready? Our goal is to get those 2 angles. That's what the proof statement says. Prove those 2 angles are congruent. They're not alternate interior. They're not corresponding. They're no relationship at all. But, ready? Let me take these 2 parallel lines first. Anybody know what type of angles those are from those 2 parallel lines? What type of angles are those? Those are alternate interior, aren't they? And they are congruent. So angle DCF is congruent to angle BAE. And again, this is one version. I'll show version 2 in a second. Parallel lines imply alternate interior angles congruent. Done. Here we go. All right. What about the other set of parallel lines right here? Everyone take a look. Boom. Boom. What type of angles are in orange now? Oh, also alternate interior. I'll just throw that right in step 2. Angle DAE is congruent to angle FCB. All right. I'm hoping we're at this point. I'm not going to hope. I expect you guys to be at this point. How do I get the big angles now? Addition, substitution. Okay, addition, substitution. Okay, so that's one version. That's one version, everybody, using alternate interior. The other version you could have used. Let's see. How do I? Let's do these 2 parallel lines first. Everyone ready? I'm not going to mark them congruent. This angle. Let's see. Boom, boom. Nope, I got to go up here. This angle right here and this angle right here. Why are they supplementary? What type of angles are those? Same side interior, so they're supplementary, right? Okay, let me take the other 2 parallel lines down here, AB and DC. Ready? Why are these 2 right here, all of angle A and D, why are those supplementary? They're same side interior. So both of these angles are supplementary to angle D. So they have to be congruent to each other. Supplements of the same angle are congruent. 2 different ways to do it. Okay, 2 different ways. But again, didn't have anything to do with the index card theorems. Couldn't use them. No use. All right, we good? You guys at home, do what you got to do. Clean it up. Submit it if you want. You got till 1 o'clock. You guys here, let me take a quick peek. What's up, Emma?
Oh, I'm just itching.
Just itching the head, all right. Do what you got to do, right? All right, let me see what you guys got because we got a full day Packed day today. Packed. Sure you're going to be happy to hear this. Little Algebra 1 review. Today, little Algebra 1 review. Yeah. Slopes. Anybody? Slope? Sound familiar? Maybe 7th grade, somebody told me first. I think she was trying to show off, but somebody told me first period. You guys did this in 7th grade, probably last year too. All right, here we go. And I'll tie it all in. Why is this in the parallel and perpendicular line unit? We'll tie that in at the very end of class today. First thing I need from you, what do you know about slope? If you want to tell me the formula, go ahead. Anything you know about slope. Let's open this up here. Let's go big time. What do you got, Radhika? What do you know about slope? y2 minus y1 over x2 minus x1, everyone. There it is. Usually, and I'll be honest, that's the first time in a couple years that the first person who answered my question got it right. Very first thing, usually, and it happened first period, people tell me, slope, y equals mx plus b. You were probably thinking the same thing. That's the equation of a line. That has nothing to do with slope. Well, slope is the m part of it, but that's the equation of a line, kids. All right. Slope formula, though. Change in y over change in x. Yep. y2 minus y1 over x2 minus x1. Also, I'm going to give you this one, too, because this formula I just gave you with the y's and x's is great if you know the points. But let's say the line has been already graphed for you, and you want to find the slope pretty quickly without finding points and plugging it in. Anybody also heard of rise over run? Yep. I always use that one when it's on a graph because it goes quick that way. All right. Okay, couple pictures here of different types of slopes. I got a positive slope that goes uphill, left to right. I got a negative slope that goes downhill, left to right. These two kids get confused a lot. This is a graph of a slope equal to the number 0. Equal to 0. By the way, what type of line is this? Don't tell me straight. They're all straight. Oh, boy. Come on, honors kids. And you guys are strong. This is a strong group, too. This is a horizontal line. Good. Horizontal. Yes. It's like the horizon. They teach you that in elementary school. And then undefined slope. Undefined. This is a vertical. Undefined means it doesn't exist. There is no slope. Different from equal to 0. Okay, good? So that's what all the different slopes look like. Perfect. All right, let's get going. You probably remember writing equations of lines last year. There are 3 types, 3 ways we could write the equation. A lot of you guys know y equals mx plus b. That's coming up in a second. First way I'm going to show you, and I don't know if they still do this in Algebra 1 or not, is called standard form. Standard. That means my x, my y are all on the same side of the equals. Okay, all on the same side. So look at my equation. 6x plus 3y equals 12. Notice the x and the y are on the same side. This is a great form if you had to graph quickly. All right, if you had to graph quickly, this would be a great form to have your equation in. Here's why. You could find what's called the x and the y-intercept very quickly when an equation's in standard form. I'm not expecting you to graph it. I'm just going to graph one up here for me. Real quickly, everybody. Anybody know what I mean by the x-intercept? That's where my line does what? My x-intercept. Kyle, go ahead.
It goes through the x-axis.
That's where it goes through the x-axis. So right now, guys, real quick for me. What do you know about every point on the x-axis? What's the y-coordinate of every point on the x-axis? 0. And I ask you that because that's how you guys are going to find the x-intercept. You're going to take the number 0 and plug it in for y. That's how we find the x-intercept. So here we go, guys. For this equation I gave you, 6x plus 3, plug in 0 for y, because every y-coordinate on the x-axis is 0, equals 12. Solve for x. Pretty quick, right? Pretty quick. 0 times anything is 0, so I get 6x equals 12. What's your x-intercept? 2. So here, look. 1, 2 on the x-axis. There's my first point on the line. And then how do you think I can find the y-intercept pretty darn quickly? Plug in 0, 4, x. Yeah. By the way, did I put... Yeah. I even gave you guys a graph, huh? All right, let's do it now. Look at that. Mr. Carlino. Woo! So 6 times 0 plus 3y. Period 1 didn't even tell me I gave him a graph. 3y equals 12. So y equals 4. Yeah. So on the y-axis, go to 4. And look. 1, 2, 3, 4. I got my line. I only need 2 points. All right. I'm not. Don't get out of straight edge or anything. You guys can just freehand this bad boy. But there it is. Woo! Come on. Maybe I need one. There we go. There's your line. I can graph it pretty quickly when it's in standard form. Oh, we're not done yet, though, are we? We've got one more question to say. What is the slope of this line? And remember, it's already graphed for us. I really don't want to waste time doing y2 minus y1. If you want to do that, that's fine. All right? However you feel comfortable. This is already graphed for me. And I know where 2 of the points are. So I can just do a little rise over run real quick. All right, here we go. I'll start from the lower point here. You guys can count. How many do I rise and how many do I run? Up. 1, 2, 3, 4 over 2. So I have 4 over 2, which reduces down to 2. But what is that? Unfortunately, nobody's getting credit for that. Nobody's getting. Hey, quickly! Look at my line. Ready? Look at my line. Woo! Not positive 2. What type of slope does it have? Negative. So I got to put in negative 2. There you go. So pretty nice when it's in standard form. We can graph really. It's not the best to find the slope unless we graph, but it's easier to graph when it's in standard. All good on standard form. X's and Y's same side. Everyone at home, good on standard form. All right, moving along. This is what everyone's familiar with. The next form, which is slope intercept. Our good old y equals mx plus b. M is for my slope, and b is for my y-intercept. Yep, where it crosses the y-axis. Woo! All right, so here's your first equation. I take it easy on you here first. 4x plus 2. That's in slope-intercept form already. So you can pick off the slope and the y-intercept pretty quickly, and this is where I'm going to start turning it over to you guys. Let's roll. Here we go. St. John, how about my slope of this line?
The slope is 4.
4, and how about the y-intercept?
2.
Positive 2. There you go, guys. Not too bad. Ooh, but what happens if it's in standard form? And I need the slope and the y-intercept? What am I going to have to do to the standard form? Go ahead, Maeve. Change it to slope-intercept form. In a nutshell, solve for y. Get the y all by itself. What's your first move then? What's your first move with my standard form equation to get it y equals? 2's. Hannah, here we go. What's your first move to get y by itself?
Move over the negative 6x.
How?
Addition.
There you go, everyone. Add 6x. Add 6x. 3y equals 6x plus 12. Good. What's our next move here? We're almost there. 9. Here we go. Audrey, what's your next move?
Divide by 3.
Thank you. So we end up with y, which I needed. Divide everything by 3, just not the first number, everything. 2x plus 4. Now you can give me slope and y-intercept. Go ahead. Boom. What do we got? 3. Omni.
The slope is 2 and the y-intercept is Yeah, 4, 0. Or
Y-intercept was what?
the y-intercept is 4, 0.
No, well, that would be because if you graph 4, 0, that would be on the x-axis. So that wouldn't be my y-intercept. See what I mean?
Right, you divide everything by 2, right?
Remember, hey, just tell me it. Remember, slope, y-intercept. So you can just tell me 4. You don't need to give me it as a coordinate. Just say 4 on the y-axis, okay?
So you don't want it as a coordinate?
No. Nope. Nope. Just say 4. Because if you tell me y-intercept, I automatically know I'm going to the y-axis. So once you tell me the number, I'm going there on the y-axis. All right, everyone else good? Standard form, slope-intercept. And I have confirmation from period 1 that you have heard about the last type, which is point slope. Point slope. Maybe not last year, 7th grade, maybe. I don't know. Personally, don't care. All right. So point slope. How does point slope work? It's exactly as it's titled. Point, that's what I plug in for x1 and y1, a point on the line, and slope, that's what your m value is. Well, what do you plug in for the other y and x? Nothing. That stays y and x. Okay? The only thing I plug in for, x1, y1, which is a point on the line, and m, which is your slope. Mathematicians are crazy, huh? Point slope. You plug in a point and a slope. Unbelievable, those guys. Let me tell you, or ladies, sorry. You never know who made them up. All right, so I have an equation here. Point slope form. Can you guys pick the slope off for me? Point slope form. Pick the slope off here for me. Oh, 2. Here we go. Quincy, what's the slope of this one? That's already in point slope.
Is there wait? So does that show it, or do you have to simplify it? I'm a little bit confused on point slope.
Okay. See my equation of point slope up here. Which variable represents the slope?
The m.
Okay. What is in place at m?
So 3.
There we go. Everyone's all good? Can you rewrite it in slope-intercept form, what we just talked about? Basically, take that equation and solve for what variable? Y. All right, let's see if anybody can do it. Because there's a couple of things we need to accomplish here. All right. Settle down, man. Sophia, what's your first move here to get that into slope-intercept? You got a couple first moves, but the one you want.
I would multiply, or I would distribute 3
Yep.
to the x and 1.
I like that a lot too. You could bring the 4 over, but I like doing the distribution first. Now bring the 4 over. Yep, bring it over, everybody. So y equals 3x plus 7. Oh, and look, what's still the slope? 3, no matter what form it's in. It's always 3. All right. Questions, comments, any concerns? Oh, you're hungry. You want more, you said. You got it. I'll give you more. I'll keep feeding you. We got to talk about horizontal and vertical lines now because they're a little bit different ballgame. They're equations. So could you do me the following on whatever graph you have in front of you? Draw a horizontal line through 5, -1. Find the point. I always get a chuckle out of this. Where is 5, -1? What is a horizontal line? Is that up and down, left and right? Oh, I'm just going to wait till he does it. Oh, there we go. All right, I need somebody to name 3 points on that line we just drew in. Can you give me 3 XY coordinates? 3 points on that line. Let's do it. Come on. Oh, here we go. Omni, going back to you. Can you give me 3 points on that horizontal line?
-8, -1, 2, -1, and -2, -1.
Thank you. And I also thank you, Omni, for being the kid, because every couple of years I get the kid that goes 162 -1. You know, that kid's usually annoying. I'd like to throat punch him. All right, so thank you for not being that person. All right, Omni gave me 3 great points. What do all these points have in common? -1 as their what coordinate? Y coordinate. They have -1 as the y coordinate. And why do I stress that so much? Because that's the equation of this line. Y equals, what's all the y's equal to? -1. Okay? Every horizontal line is y equals. Go ahead, do it for a vertical line now, but now it's got to go through 4, 3. So find 4, 3, and draw a vertical line through. And give me 3 points on that line now. Can you help me out? 3 points on the vertical line. 6. Caroline.
4, 1,
Yep.
4, 2,
Yep.
4, 5.
Thank you. Good job. Good work. All right, what's in common here, kids? Every x is equal to 4. So my equation for a vertical line is going to be, in this case, x equals 4. Every x is equal to 4. All right, can we just sum up what we just did here? Here we go. Horizontal line. Horizontal line is always, any horizontal line will have the equation y equals a number. By the way, that's the number symbol, not hashtag. All right, I'm not trying to trend here on Twitter. All right, that's just the number symbol. I don't know if some of you young bucks know that or not. And then what about a vertical line? Any vertical line will be x equals a number. Okay. And you know, every year I get a couple kids that say, is there an easy way to remember that other than memorizing? There is. This is what I use. I don't memorize which one's x, which one's y. Here's how I always see it. Everyone think of about a horizontal line in your mind right now. Think of a horizontal line on a graph. What axes does it always go through? The y. So that's how I know every horizontal line starts with y, because it goes through the y-axis. And vertical goes through x-axis. So that's why I know it starts with x. If you want to use it, fine. If not, forgive me. Anything else? Questions, comments? It's getting a little rowdy back there, huh? All right, here we go. Whew. This is getting nuts. All right, we got to write the equation of a line and slope intercept. It's got to be slope intercept, which was y equals mx plus b. Yep, so every answer here has got to be y equals. All right, number 1, I just spoon-fed you, didn't I? I gave you what m is, and I gave you what the y-intercept is. You're welcome. So it's got to be in this form. So you got to know what the m and the b are, and you know both in here. So what's the equation for this one? Oh, please not me. Let's go, Emily. What do you got back there?
Y equals 3.
Yeah, just plug in 3 for the slope, 4 for the y-intercept. We're on our way. That's nice, huh? That was nice. Well, what about if I give you one and not the other? Take a look at 2. I gave you the slope, but I didn't give you the y-intercept, did I? I gave you a point on the line. Okay. Ooh, I still need b, though. You're not getting away from that. I still need b. Couple different ways we could do this. Couple different ways. I gave you a point on the line and the slope. We could put this into what form first? I gave you the point on a line and the slope. I could put it into what form? Point slope and then convert it to y equals like we did a couple problems ago. That's one way. Another way, which is I think most of you learned, is actually plug in for y, m, and x and solve for b. I think that's most of the way. Yes, no, maybe? Yes, we're familiar with that. But again, if you want to put it into point slope and convert into y equals, go right ahead. Now, what do I mean by plug in? Here's what I mean. Y. Do I know a y coordinate that this line goes through? What's the y coordinate? -4. Do I know the slope? And do I know an x coordinate that it goes through? Okay, so I use that same slope-intercept equation to plug in for y, m, and x and solve for b. And I don't need to ask anybody how they're doing their algebra. B equals -2. All right, put them both together now. What's the equation of this line then? Put them both together. 10. Atticus, put them both together. What's the equation of number 2?
Y equals mx minus 2.
Mx? Don't I have to plug in for m?
Y equals -2x minus 2.
Where's the 2 coming from? What does m represent in mx plus b?
The slope.
Okay, and if you look at number 2, they gave us the slope.
Y equals -1x minus 2.
Okay, everybody good? Okay, for time's sake, because I'm running out of time, I'm going to skip over 3 and going right to the next here. So why are we doing all this today? How does this tie into what the unit's called? Because we can also deal with parallel lines and perpendicular lines. Do you guys remember anything about parallel lines other than I get it, they don't intersect? Anything else? Because remember, what's today's topic? What's today's topic? Slope. Any relation between slope and 2 parallel lines, babe? Same slope. So here you go. If 2 lines are parallel, their slopes are equal. Perfect. Yes?
Can I also write that if there are 2 lines with the same slope that parallel?
Correct. Yep, same thing. All right, here we go. So can you guys write an equation of a line that's parallel to -1x plus 4 and goes through -2,5? So it's got to be parallel to that and goes through -2,5. First question for somebody. Here you go, Emily, back to you. What's the slope of this line they gave me? Okay, so watch my notation. M equals -1. That's the slope of the line they gave me. All right? And again, I just told you, you guys are looking at me like I have 2 heads. I told you I was skipping over number 3. Okay, we're going on to the next one. So what would be the slope? Watch my notation. Parallel symbol, right? What would be the slope of a line parallel to that one then? Also, -1. They're equal, you told me, right? What's the only thing I'm missing from y equals mx plus b now? I got the slope. What's the only thing I'm missing? The y-intercept, the b. But I know a point it goes through. So I can substitute it in. What's the y-coordinate it goes through? 5. The y-coordinate equals, what do we just find the slope of this parallel line to be? -1 times, what's the x-coordinate it goes through? -2 plus b. Find your y-intercept. Equal to 3? Okay, put the 2 together. What's the equation of my new line? Y equals Negative 1x plus. Got it. Well, parallel lines, same slope. Anybody remember two perpendicular lines? If two lines are perpendicular, their slopes are
Opposite?
blank. That is half of it. Okay, we had the word opposite just discussed in class. That's part of it. It's more than opposite. Yes, so one will be positive, one will be negative, but I have to upside down. Can I get a mathematical word, please, other than flip or upside down?
Inverted?
Invert. I need something better than that. Begins with R, ends in reciprocal.
Reciprocal.
Oh, reciprocal. There we go. They are negative. Oh, boy. Negative reciprocals. Flip them. Turn them upside down. Make that frown upside down. Yep, great. All right, so let me just quickly do this problem here. What's the slope of this line that I gave you? 4. So the slope of the line perpendicular, flip and change the sign of it. So the perpendicular line, flip and change the sign, will be negative 1/4. And I already gave you the y-intercept here, which is 8, so plus 8. All right, perfect timing. Woo! Good job. I warned you it was going to be packed. I'll see you guys on Monday. Woo! Good session.
I took it when I was doing my final grade. What'd you get on the test today? On bio, 97. That's so good. You did better than Rue. I did. Ash, you got an 87. Oh my god, life goals, bro. I got an 81.
Thank you.
Hi, guys.